So that's kind of exciting. I hope you like the new intro. It's very lame. Um, and I showed my mom, and she made fun of me for it. So you guys can feel free to make fun of me as well. Um, what we're going to do today, as mentioned, is we are going to go through. Let me share the screen with you. Go live. We're going to go through theoretical yield, percent yield, actual yield, and what those are. So I posted the website here. It's also in your Physical Science 20 Google Classroom. It's already there. So basically, what theoretical yield is, or what percent yield, um, when we're calculating and when we've done all of these stoichiometry calculations, what we have been calculating so far, um, what we have been calculating is always theoretical yield. So this is the idea that this is the absolute maximum amount of product, or the expected amount of product that we should be able to make. So this is the expected or maximum amount of product that we could theoretically make. In a real lab, you will be extremely fortunate if you're able to get the theoretical yield, or actually if you're even able to get close to the theoretical yield. There's a lot of variables, and I'm sure throughout science, in your high school or in your elementary career, I'm sure you've heard the term sources of error. Sources of error, I mean, it's when you're younger, and I honestly didn't understand what a source of error was, or like how it totally operated, or what actually met the qualities of a source of error, until I got to my honors project in my 4th year of biochemistry. Honestly, sources of error can come from everywhere. It can come from the tools that you're using in the lab. It can come from the way that you are isolating, or the way that you're separating out your product. It can come from the temperature of the room that you did your experiment at. There is a million sources of error that can exist, but to qualify as a source of error, it needs to have a significant impact on the result of your experiment. And so what we're going to talk about today is I'm going to show you how to calculate what you would have expected to get versus what you actually got. So the actual yield, let's make a note of this. The actual yield is the measured amount of product that you achieve at the end of an experiment. So the actual yield is like, I actually received, or I actually produced 6 grams of this. And then the percent yield is the comparison between the theoretical and actual yields. It is represented by the following formula. So again, if we were in the actual science lab at SCS, we would be doing this over and over again, and you would get very accustomed to this. But the formula is that the percent yield is equal to the actual yield. And I can't draw straight lines with this tablet, so I'm just going to do this. Actual yield divided by the theoretical yield times 100%. So this formula is very similar to how you would calculate your grade at the end of an exam or on an assignment. The theoretical yield would be like the possible number of the possible number of questions on the exam. So like if I gave you an exam that was out of 10, if you got 100%, it would be 10 out of 10. If you did an experiment and the theoretical yield, so what you calculated was 26 grams, and you got 26 grams as your actual yield, you would get 100% in terms of your percent yield. Let's say that you only got, you had 10 grams that you could have in theory produced, but you only produced 9 grams when you actually did the experiment. Your percent yield would be a 90%. So that's kind of the idea, is you just compare like, how much did I actually get? How much should I or could I have gotten potentially, or theoretically? And then you compare those two numbers and multiply them by 100%. So we're going to do a couple questions here. There's two different types of percent yield questions that we'll do. So this is question number 1. Let's insert a line right here so we know it's separating those two. This will be question number 1 there. And this gets messed up in OneNote, so I'm just going to fix that. So the question is asking us for C6, I still need more space, of sorry, I screwed something up here. C6 H6O3, H6O3. And the question that is on the website here, it gave us sorry, I don't know why that's being funky. Anyways, the question, it gave us the balance formula. It gave us C6 H6O3 plus 6 oxygens goes to form 6 carbon dioxides and 3 waters. So it says for the balance equation below, if the reaction of 40.8 grams produces a yield of 39%, how many grams of H2O would be produced? So what we are going to do is we're going to do the exact same thing that we normally would have done. We want to start with the thing that we have both a number and unit for, which is 40.08 grams of C6H6O3. And then we want to convert 2 grams of H2O. And then we want to multiply that by 39%. So when we do this question, we're going to start with 40.8 grams of C6H6O3 times sign line. And I know I'm going to convert that into moles of C6H6O3. The molar mass of that would be 12 times 6 plus 1 times 6 plus 16 times 6. So 12 for the mass of carbon, and there's 6 of them. 1 for the mass of hydrogen, and there's 6 of them. And then 16 for the mass of oxygen, and there's 6 of them. And then you get a total molar mass there of 174 grams of C6H6O3. Similar to what we've been doing all throughout this class. I really can't draw straight lines with this. We're going to draw a straight line. We want to convert from moles of C6H6O3, and we want it to go to moles of H2O. And so based on the balanced chemical formula, there's a 1 out in front of my C6H6O3. There's a 3 in front of my H2O, so I know that for every 1 mole of C6H6O3, there's 3 moles of water. And then again, the molar mass, so looking at this here, the molar mass in grams always is equivalent to 1 mole. So one of the things I noticed just talking with a few of you is that some of you still want to put a 3 here. That is not correct. We've already represented that 3. And that 3 is only used to convert between moles of different things. When we're looking at this molar ratio, so this is the molar ratio, we want to compare 1 mole with the molar mass. And I know that the molar mass of water is 18.0148 grams of H2O. And you can check with that later, but hydrogen has a mass of 1.0079. There's 2 of them. Oxygen has a mass of 15.999, and there is 1 of them. So we could spit this question out then. 40.8 divided by 174, multiplied by 3, multiplied by 18.0148. And you get 12.67 grams of water. 12.67 grams of H2O. And what this represents is this answer here is your theoretical yield. So as I said, when we were calculating all of these answers, whatever we calculated at the end of our time sign line, that was our theoretical yield. In theory, that's how much we could produce. But in this question, we were told that it produces only 39% of that. And so what I need to do with that number is I need to take that 12.67 and multiply that by 39%. So in other words, what I'm going to do is I'm going to take 12.67, and a percent is out of 100, so I would divide 39 by 100 to end up with 0.39. And when I do that, I end up with a final solution of 4.94 grams, like such. And there you go. So that's the first one there. That's the first type of theoretical yield question. As I was going through, I haven't seen many questions like that. Those questions tend to be a lot more rare than these other types of questions that we're going to look at. So question number 2 here. Question number 2 gave us the balanced chemical equation again, which was CaCO3 goes to form CaO plus CO2. Again, these questions are all just from the website that I have shown up at the top here, this limitingreagents.weebly.com. That's where they all come from. Okay, so for question number 2 here, for the balanced equation shown below, if the reaction of 20.7 grams of CaCO3 produces 6.81 grams of CaO, what is the percent yield? This is a far more common type of question that I would expect. So what this number here is, this 6.81 grams, this is the actual yield. So they've told us how much this experiment has actually produced. We need to figure out, we don't know what the theoretical yield is. So in order for us to calculate the percent yield, which is what this question has asked, in order for us to calculate percent yield, we need to either figure out the theoretical yield or the percent yield. And in order to do this question, we have to first figure out theoretical yield. So we're going to start this question with the 20.7 grams of CaCO3 times sign line. I know I'm going to convert into moles of CaCO3. In terms of figuring out the molar mass, calcium has a mass, I believe it's 40.08. Carbon has a mass of 12.011. And oxygen has a mass of 15.999 or 16. Let's just check calcium. So that total molar mass there should equal 100.09. 100.09 grams of CaCO3. And then what we want to do is, using the balanced equation, we want to convert from moles of CaCO3 into moles of CaO. So 1 mole of CaCO3, so 1 in front of this number here, and that converts into 1 mole of CaO. So also 1 in front of this number. And then the last step is to convert from moles of CaO into grams of CaO. Molar mass is 40.08 for the calcium. 40.08 for the calcium and 16 for the oxygen, which gives us a final molar mass there of 56.08. Plugging all of that into your calculator, 20.7 divided by 100.09 times 56.08 You get 11.6 of CaO. And so this then is your theoretical yield. So what you'll notice, and you should always notice this, your actual yield should always be lower than the theoretical yield. If it's not, then like the story I was telling yesterday, the experiment person, the experimenter, I guess would be their title, they cheated and they probably threw some extra chemicals in there and they're lying to you. So now what we need to do, the question asked us to calculate the percent yield, which as we said was equal to the actual yield and that was divided by the theoretical yield. And we want to multiply by 100%. So when we do that, percent yield is equal to, the actual yield was 6.81 grams. So 6.81 grams. And the theoretical yield that we calculated was 11.6 grams. And we want to multiply that by 100%. When you do all of that in your calculator, 6.81 divided by 11.6 times 100%, you end up getting a percent yield of 58.7%. I would multiply it by an actual 100. So the reason I'm saying multiply by 100% is because what we actually have here is if I plug in all the units, I have grams of CaO and grams of CaO. Those two will cancel out. So what the percent acts like here is this acts like the unit. So if I were to, you're right, like if I were to talk about 100% as a decimal, 100% as a decimal is just 1. Is equal to 1. But when you guys are figuring out your grades in your calculator, for example, if you were to, I don't know, let's say you were to get 9 out of 10, you would on your calculator see 0.9. But you know you didn't get 0.9%, you know you got 90% if you got 9 out of 10, right? So 9 out of 10 is equal to 0.9. You know to multiply by 100, you got 90%. And what you're actually doing is multiplying by 100%, where that percentage sign is like acting as the unit. Does that make sense? Okay. That was another thing that was really, I learned something when I started doing some math tutoring last year, and that was percentages, how to work with them and how to, I guess, how to manipulate them a little bit more and like what a percent actually was. I felt like that was really valuable to learn at Mathnasium. But yeah, basically what we're doing here is, you're right, like if this was a decimal, you could write 0.587, but that doesn't communicate much information to somebody. That doesn't tell them like you will get half or about half of what you should have gotten. So 6 is half of 11.6. And that's why we multiply it by the 100%, is just to say like out of 100%, you got 58.7%. So again, that serves as like your grade or like the quality of lab that you did. That's a good question though, Tegan. I was going to explain that, but I wasn't sure if anyone would find that interesting. Does anyone have any questions so far?